Hey everyone, how is it going today? My name is Maddie, and welcome back to another episode of Tech Insights for Visionaries. In this podcast series, we discuss the latest technological trends and the ways they affect our businesses. Every entrepreneur, startup owner, and enterprise leader should always keep up to date with the latest updates in technology so they can keep their business relevant and competitive. This podcast is produced by a team of software engineers from MobiDev, a US-Ukraine software engineering company focused on helping visionaries create their products. The company invests in technology research and has years of experience building AI-powered solutions, web and mobile platforms, implementing augmented reality, and IoT technologies. Feel free to reach MobiDev to create your next product.
Hi guys, Sean here. As many of you are already aware, security has been a huge issue these past few years. One of the most helpful technologies for providing enterprise-level security is single sign-on, when users only need to log into only one application and don't need to log into other applications during that same session. Efficiency is improved greatly. This is accomplished by setting up a reliable relationship between an application, known as a service provider, and an access management system. A service provider and an access management system share a certificate with identification data, which in this case of SSO takes the form of tokens that include email, username, or other data. However, a lot of businesses find it difficult to incorporate single sign-on into their infrastructure. I think it's a good idea for us to talk about what types of SSO implementations there are, some pros and cons of SSO, best practices, and then we'll talk about our own approach to creating SSO applications here at MobiDev.
So, what are the different types of SSO?
Single sign-on is part of the Federated Identity Management, FIM architecture. When we talk about federation, we mean multiple networks, enterprises, or domains. In this case, this means that FIM can help us verify digital identities across domains, applications, and even other businesses. Single sign-on can use a few different protocols, such as Security Assertion Markup Language, or SAML. It also can use Web Services Federation, OpenID Connect, Lightweight Directory Access Protocol, and Kerberos.
So why should businesses use SSO?
One of the big reasons why businesses use SSO is because it's faster and easier, while remaining relatively secure. SSO can help reduce password fatigue. It can also help enable more efficient business-to-business collaboration. These kinds of partnerships work well with federated SSO because users can easily access services across different companies with the same credentials. Faster login times mean higher productivity as well. SSO also has a high adoption rate and increases the probability that users will open apps more frequently.
Those sound like some pretty good reasons. I can imagine that there might be some security vulnerabilities that surround SSO. If there's ever a security breach, the attacker may have access to many different types of services instead of just one.
That's exactly right. There's a risk of this occurring, and the attacker's footprint can be larger because of that. However, SSO can reduce the number of opportunities for attackers to scalp login information because users log in once per day and only use one set of credentials. A higher level of security may be achieved if you combine SSO with risk-based authentication, RBA, identify unusual behavior, and require users to pass additional verification. Another main disadvantage of SSO, unrelated to security, is that if SSO fails, users won't be able to access any of the applications that the software was designed to be a gateway for, effectively shutting them out of the entire network.
So, what are some best practices for businesses to make the most out of SSO and avoid vulnerabilities? Is SSO difficult to implement?
Those are some great questions. In the past, setting up SSO for native applications was a complex challenge. There were two options available for developers to display content in the apps with SSO. They could switch the user from an app to the system browser, and then back, or display an in-app WebView for rendering HTML content directly into the app. These options are either inconvenient for the user, or they have security and privacy issues. However, a third option has emerged: SF Safari View Controller for iOS version 9 and newer, as well as the Chrome Custom Tabs feature for Android. These add a web controller to provide all the advantages of the native system browser that benefited developers greatly. For us here at MobiDev, we have experience with SSO implementation between two mobile applications built with different versions of native script, App 1 and App 2. However, the described approach to SSO is identical for both native and cross-platform applications. App 1 is mobile, while App 2 implies the combination of mobile and web, where problems with the transition to the new version are expected to arise. The identity provider for authorization through OpenID Connect, OIDC client, is common within applications, which facilitates the start. We have three options to choose from: WebView, System Browser, and In-App Browser.
How does single sign-on work with WebView?
When we use the WebView implementation, we'll use it to log into the first application. The second app will use In-App Browser, a well-known method in the world of hybrid applications. This uses Chrome custom tabs for Android and Safari Services Authentication Services for iOS under the hood. We did some research that showed us that there were three accessible options to implement SSO that met our criteria. The main mechanism of this method is that it shares cookies across applications. WebView is embedded into the native screen of the application, similar to an iframe, which can be perceived as the advantage of this method, since the navigation during logging in looks natural for the user. This is because animations and styles don't stand out. The major issue of using WebView for logging in is the delay in the callback related to page loading. To get around this issue, our team came up with ideas on how to understand exactly when the login form on the web page would load, so that they would be able to hide the indicator. Otherwise, it would be shown over the already loaded login screen, or be hidden before the screen was loaded. This glitch could lead to problems with the review of the app submitted to the App Store. There were also problems with accessing cookies on Android, and it's difficult to set up a common login without opening external links that use SSO.
What about the device's system browser? How does this method work?
A system browser would be really easy to set up SSO implementations with, but it does require the extra step of the user leaving the application and opening the browser to fill out the login form. Tabs with logins remain unclosed in the browser and accumulate. It's easy to implement because everything works the same way as on the web, and both applications will open a login form in the same environment with the same cookies that the OIDC client applies to verify the user. With the current setting of the server identity for both applications, everything works very smoothly. The only issue is that it's not the most comfortable for the user.
What about the in-app browser?
In Android and iOS, tabs can be customized in systems as native pop-ups with platform animations and appearances. They track redirects and are closed if a login is entered correctly. There isn't a problem as in the case of WebView, although the login form will look detached from the application if the design differs from the native platform's components. We recommend this as a safe approach to SSO implementation in mobile applications. After some trial and error, we eventually decided to opt for in-app browser. This is a common sandbox with cookies inside one application. So if you apply it and then open other web links in it, this should log in the user via SSO. This eliminates various issues associated with the process. However, in two different applications, these sandboxes would be different, and you would need to somehow share information from one application to another to complete the implementation. To accomplish this, we applied keychain storage in iOS and secure storage in Android, since both of them securely store data on the device. They can isolate the storage for one or multiple applications. However, this requires additional configuration steps in each of the mobile applications. Once we were able to configure this shared storage of information, we enabled data interchange between the two applications. An additional wrapper that reproduces methods of input and output in the local storage API allowed us to introduce common local storage for OIDC Client User Manager.
Our team has gotten very comfortable working with single sign-on solutions. Can you talk more about our approach to implementing SSO?
Sure. Implementation of the steps we talked about earlier is enough for most applications, where the identity provider is initially configured for SSO between applications. But since there are some difficulties with this, we had to go further to reinvent the wheel. Let's think back to the OIDC client. I should mention that it has several different flows for logging in. You can use a username and password, two-factor authentication, and other methods. However, SSO and session updating requires the so-called code flow, which after the user enters the credentials, returns not the session token, but instead the code that must be exchanged for the object with session data. This data is the session token, the lifetime of the token, and the token for refreshing the session. To configure the token's lifetime, an identity server should be used. As usual, the session token lasts for hours or days, and the refresh token lasts for weeks or months. Long-lived refresh tokens may serve for login with biometrics in a mobile app. Our general process with this is to first read the biometrics data, then return a refresh token. After that, the user can obtain a new session token. Finally, the user can then access the application. This token update isn't noticed by the app user because it happens in the background. A simple update of the token grants the user access to the application. This makes the login run smoothly and can be used in both applications. When using SSO between mobile applications will require opening the browser, WebView, or in-app browser, our goal was to create a system that was more convenient and would suit as many different applications and needs as possible.
Sometimes with this topic, we talk about deep linking. What does this mean, and how does it work?
Deep links will send the user directly to a specific in-app location. So we can open one application directly from another through the SSO process. When the user opens a deep link through App 1, App 2 is then opened. Before opening a deep link, App 1 will generate a unique token and store it in a common secure storage location for both apps to see. This is then inserted into the deep link as a parameter and processes the click. The approach is implemented for security purposes. No one else has access to this shared storage, and it's impossible to log in and automatically go inside another application by using a deep link from the outside. The unique token that was generated includes a timestamp, which defines a period during which it is valid. It also contains a username, data needed for security, and verification of user data, and random things to prevent guessing and brute force attacks. When the user is sent to App 2 with the deep link token, the app parses the token, compares it to the one in the shared storage, and then checks the user's identity. The time from the creation of the token should be approximately 1 second. Only after this will App 2 obtain a new token via the refresh token that uses the biometric login of the app under the hood and redirects a user on the screen added in the deep link. This only works if App 2 has a valid refresh token that hasn't expired. Biometric login must also be enabled. Otherwise, users will still have to enter their data manually, as if the token or the username does not match. Once the user is logged in, it's still possible to send the user directly to the necessary application screen. Every application will have its own settings and IDs that are unique in the system of the identity server. All changes can be made by UI teams, and the solutions will work with any identity providers that have code flow.
So we've covered a lot about single sign-on so far. What's our main takeaway here?
Well, companies are really investing in SSO. In fact, single sign-on will be a $2.2 billion market by 2027, according to Research and Markets. Google also offers pre-integrated SSO with over 200 popular cloud applications. Here at MobiDev, we have a lot of relevant expertise and familiarity with SSO solutions. If you're looking to unite apps that aren't already supported with SSO, working to develop a unique solution for your needs may be the best option.
If you need that unique SSO solution for your business, we encourage you to reach out to us so that we can have a discussion on how we can best fit your needs. Whether you're starting from scratch or just updating your system's security, we have you covered. All you have to do to start the conversation is contact us via our email, contact@mobidev.biz.
Thank you for listening to our show today. If you're interested in learning more about the latest technological trends, please subscribe to us and share your favorite episodes with your colleagues and friends. Thank you for listening, and we'll see you on the next episode.
See you soon.